Quadrilaterals, Section 3, Video 1. In this section, we're talking about properties of quadrilaterals. In the previous section, we talked all about the definitions of quadrilaterals, but definitions are limited. They are usually only one or two things, and they tell you exactly what defines that quadrilateral. But properties are things that you also get if you know you have a certain quadrilateral. So if we look at the properties of a parallelogram, we have 5 extra properties that we haven't even talked about yet. The definition of a parallelogram we know is that they have 2 pairs of parallel sides. That's all we know so far. So if I have my parallelogram, all I know right now is that this side is parallel to this side, and that side is parallel to that side. But because of those parallel sides, we get a whole lot of other properties as well. So our first property is that opposite sides are equal, which makes sense because we know that if one side, if we trace this and then it got more narrow or more wide down here so that one side was longer than the other, those sides wouldn't be parallel. So that's a property of a parallelogram that we know. Another property is that opposite angles are also equal. Similar logic there. We can also break it up into congruent triangles and prove things with the parallel lines and the angles. Another property is that the diagonals bisect each other. This is to say that if I draw a diagonal this way, I draw another diagonal this way, this half is the same length as this half, and this half is the same length as this half. And that also has to do with congruent triangles. The fourth property is that the consecutive angles are supplementary. Which can be shown with the parallel lines to say that this angle plus this angle, because of same side interior, are going to add up to 180. Or you could say that this angle and this angle are also same side interior, since both those sides are parallel. Our last property is that diagonals, which I've already drawn in, form 2 congruent triangles. So as I said previously, that's how we can prove a lot of the opposite sides, opposite angles, and diagonals bisect each other by looking at those congruent triangles within the parallelogram. Now if we move down to the properties of a rectangle, those are additional things besides what we already know about rectangles. And we know a rectangle is a parallelogram and it has 4 right angles. So since we know it's a parallelogram, it also inherits all the properties of a parallelogram. That's to say that if we have a rectangle, we know it's a parallelogram, so we instantly know it has 2 pairs of parallel sides. We also know it has 4 right angles. And we also know it has all the properties of a parallelogram that we just stated above. So we know that opposite sides are equal, opposite angles are equal, diagonals bisect each other, just in the same way. Consecutive angles are supplementary. Well, they all add up to 90, or they all are 90, and so if you add any of the consecutive 2, they'll all add up to 180, and diagonals form 2 congruent triangles. But a rectangle has one additional property that just parallelograms do not have, and that's they have congruent diagonals. So that's to say that they're the same length, which makes sense. If we had slid it so it's not a rectangle, it's more of a parallelogram, that's when the diagonals kind of get uneven. So we could even erase these lines and say, here's my two diagonals, and this is equal to this, but it's also equal to that, and those are all the same lengths because they're all congruent. Properties of a rhombus. If you know you have a rhombus, you get these properties. So all we know about a rhombus is that it's a parallelogram and that it has 4 equal sides. So parallelogram. And we also know that all 4 sides are the same length, so you can mark it up like that. Similar to the rectangle, we know it inherits all the properties of a parallelogram. So all 5 that we mentioned already. It also has a couple additional ones. Diagonals are perpendicular to each other. That's to say that if we draw one right there and one right there, that this is going to form a right angle. And that's due to the congruent 4 sides, which form those like 4 right angles in the middle. And then another property we have for a rhombus is that the diagonals also bisect the angles. So that's to say that this is equal to that. And that's the same in all 4 corners. And lastly, we have the properties of a square, which actually just inherit all of the properties. So it inherits the properties of a parallelogram, because it is a parallelogram. It inherits the properties of a rectangle, because it is a rectangle. And the properties of a rhombus, once again, because it is a rhombus. So once again, these are additional properties that we get when we know we have a certain quadrilateral. The definitions are limited to be only what exactly defines a quadrilateral, and properties are things we can get from those definitions. So they're extra above and beyond things. So I encourage you to look back at the properties of a parallelogram and really make sure they all make sense and figure out how you could perhaps prove that those properties are valid.